Okay, so design of actually loaded compression members. So mainly discussion that is for columns. So we have here some introductory concepts. Okay, so first, compression members. So structural elements that are subjected to axial compressive force only are called columns. Now, columns are subjected to axial loads through the centroid. So if the structural element is subjected to compression force only, again, important yung only, no? They are called your columns. Another member that is subjected to axial load is your truss, but since truss is both subjected to tensile force saka compressive force, no? Hindi siya kasama dito. Next is your stress. The stress in the column cross-section can be calculated as force over area. Again, babalik tayo sa deformables, di ba? Force over area is equal to your stress, where FA is assumed to be uniform over the entire cross-section. For example kasi, meron tayong cross-section nung I section or I-beam. No? Sabihin natin meron tayong I-beam. Ito yung cross-section ng column. And the top view to, di ba? Kasi column, so nakatayo siya. And then if there's a force, of course, yung force mo is nandito sa portion na to, no? Top view to, top view. Now, yung stress natin, ina-assume natin na uniform sa entire section yung stress. Yun yung kinocompute natin na FE. But this is actually your ideal state. This ideal state is actually never reached kasi imposible naman na maging uniform yung stress dun sa entire section. So, these are the causes kung bakit hindi na-reach yung ideal state. So, first, we have accidental eccentricity of loading with respect to the centroid. Or if may konting distance or wala sa centroid yung force or yung axial force. Next, member out of straightness or crookedness, kapag hindi straight yung structural member. Another one is residual stresses in the member cross-section due to fabrication process or fabrication errors. So these are the causes of the non-uniform distribution of stress sa columns natin. Okay, so the accidental eccentricity and member out of straightness can cause bending moments in the member. Now, however, these are secondary and are usually ignored. So, dito sa entire discussion natin, we are again assuming na uniform yung entire cross-section. Thus, ito lang yung equation na gagamitin natin. No? Secondary, ignored naman yung effect ng eccentricity sa member out of straightness natin. But, if a bending moment is actually present dun sa member itself, kunyari meron tayong moment mismo na applied dun sa member, hindi lang result nitong tatlo, we can no longer neglect it and then we will call it as your beam column or members with both axial compression and bending moment. Now, for this discussion, ulitin ko, this discussion, compression member lang to. The discussion for the combined axial compression and bending is for another topic. In-introduce ko lang yung beam column na tinatawag or a member subjected to both axial compression and bending moment. Ulitin ko yung this discussion is entirely for columns or members subjected to axial compression forces only. Okay, so ayun, so a column is a compression member, the length of which is several times greater than its least dimension. So columns can be classified as short, intermediate, or long depending on the value of its slenderness ratio. Now, yung slenderness ratio natin can be derived from the Euler's formula. Ito. Now, yung Euler's formula natin is given by this formula, no? Pi squared EI over KL squared. So the following assumptions are made while deriving the Euler's formula. So Ito, nung dinerive to, these assumptions are made. First, the material of the column is homogeneous and isotropic. Compressive load on the column is axial only. Column is free from initial stress. The weight of the column is neglected. Column is initially straight. Again, no eccentricity. Pin joints are frictionless, so no moment. And then no rotation. So again, walang bending dun sa column. And then the cross-section of the column is uniform throughout its length. The direct stress is very small as compared to the bending stress. That's why yung bending stress is neglected. And then the length of the column is very large as compared to the cross-sectional dimension of the column. And then the column fails only by buckling. This is true if the compressive stress in the column does not exceed the yielding stress. So this is yung PCR natin or yung critical force based dun sa Euler's formula. Ito, critical stress versus the slenderness ratio for steel. Ito, we have E is equal to 200 GPa, yield stress is equal to 240. So example lang to no, ng visualization ng slenderness ratio. Ito yung stress, and then ito yung slenderness ratio. Ito yung Euler's buckling. Ito yung stress critical stress, pi squared E, LE over R. Ito, critical load to, PCR. Ito naman, ito yung stress critical na tinatawag. Because there are times na yung question sa problem is what is the critical force? Kung yun yung tanong, ito yung gagamitin. Ito naman yung sa critical stress. If very direct yung question. Then, this is your limiting slenderness ratio. Now, if we are to analyze a column, na ang i-consider lang natin is the effect of buckling. Using your AIS specifications, we have the following. For us to categorize your column, we need to compute for your limiting slenderness ratio, CC, is equal to the square root of 2 pi squared E over Fy. Again, galing to dun sa dito. And then this is under ISC specifications. Actually, yung sa nscp 2015, we also have your LRFD and AISC. Again, yung difference lang ng multipliers nun or nominal strength is yung, ang difference lang nun is i-multiply mo, diba, sa LRFD and then divide natin sa ASD. Pero for this discussion, ito yung gagamitin natin, not that one. Okay, so yun, ulitin ko, for us to categorize yung column, compute natin yung limiting slenderness ratio. And then, or your CC, no? And then compute natin yung LE over R. Now, if your LE over R is less than CC, we are calling it your intermediate or short column. If greater than or equal, we are considering it as your long column. Now, these are the equations that we will use. Ulitin ko, kapag intermediate column, ito yung FA or allowable axial stress. Kung long column naman, ito yung allowable axial stress. Now, after we get your allowable axial stress, we will get now your, we will use your FA is equal to P over A or force over area to get the axial load that can be carried by the column. Now, what is your LE? Diba, L is the length. LE is your effective length. Now, to get your LE, multiply natin siya sa tinatawag nating buckling factor. Babalik tayo dito sa una. Diba, nabanggit ko na dito yung pag-buckle. Again, yung gagamitin natin, ang i-consider nating failure dito is buckling lang. So, ano ba yung buckling na tinatawag? Ayun, so, what is buckling? Buckling occurs when a straight column is subjected to axial compression like this one. Ito yung axial force, subjected sila sa axial compression, and undergoes a bending as shown in this figure. Now, ito yung tinatawag natin na pag-buckle or yung buckling. And then, we have different factors or variable K na tinatawag natin buckling factors. Balik tayo. LE is the effective length. Now, to get your LE, all you need to do is multiply the buckling factor to your length. So, we can say that LE is equal to K times L. So, how do we get your K, we have this. This is from AASC also. Now, kapag, again, this is fixed support. Kapag fixed at both ends, yung value ng K is 0.5. Kapag fixed, tsaka hinge, value nito is 0.7. Kapag fixed and then rotation is fixed and translation is free, pwede siyang mag-move. Yung value nito is 1. And then kapag hinge at both ends, 1 din. Kapag naman rotation is free and translation is free, magiging 2. Similarly, kapag hinge tapos rotation fixed, translation free, ito naman yung value ng K natin. Kung mapapansin nyo, these are like the elastic curve of a beam. Kung gagawin nyo lang tong horizontal yung shape ng column, di ba? Kapag fixed support, if maalala nyo, di ba, parang mag-drawing tayo ng elastic curve, straight siya sa part na to. Sorry. Straight siya sa part na to, di ba? And then, tsaka siya magdi-deflect kasi nga no rotation for fixed support. So, pwede nyo ding ma-visualize yung pag-buckle. And then, times 0.5 siya kasi ang i-consider lang natin na length is yung length ng nag-buckle. So, ito yan. This is your 0.5. 0.5. Ganon. And then, similarly, dito fixed, no? Kaya straight ulit dito. And then, ito naman is a hinge. Di ba pag hinge, meron tayong rotation. So, may ganon tayo. Yun. And we are considering this length as 0.7. And so on and so forth. So, ganon yung pag-visualize natin kung saan nakuha yung value ng K. Multiplier siya dun sa entire length para makuha yung length ng pag-buckle ng column. Okay. Okay, so general analysis of actually loaded column. First, kapag hindi, we will do this kapag hindi siya symmetrical or built-up section yung column natin. So first, locate nyo yung centroid using your Varignon's theorem. Ito, di ba? Varignon's theorem to. Second, compute the least moment of inertia. Now, using your transfer equation kapag hindi uniform yung cross-section natin. Again, kapag uniform yung cross-section, you don't need to use these two. Next, compute for the least radius of gyration. Please take note of this. Now, this is the least, the least radius of gyration. Least. Take note, least dapat, radius of gyration. Again, yung equation from your statics, radius of gyration is equal to square root of I over A. Now, please take note, in drawing your cross-section, we have your X and Y axis. So, we will get two values, IX and IY. So, we will get two values, RX and RY. So, we need to choose the least. Kung mas maliit ba yung RX or yung RY, yun yung gagamitin natin, yung mas maliit. And then next, after we get your R, so for the slenderness ratio, LE over R, again, ito na, LE is equal to the buckling factor times the length of the column. And then, solve for your CC kasi i-compare natin tong dalawa, di ba? Ito. Compare natin siya kung less than, short, kapag greater than, long. Next. Ayan. Then, ito na yung dalawang condition. Get your FA using these equations to solve for your column capacity. I will reiterate this discussion. Ang pag-design ng column is solely based on the buckling of the column. So, there are other factors, pero hindi natin yung di-discuss dito, no? Okay, so ito lang naman yung equation. So let's have here an example. So here, find the maximum axial load that the W200 by 46 column can safely carry if its effective length is 6 meters, FY248 E200. Ulitin ko, di ba, pag ganito, yung section, di ba, this is W, this is the depth, 246 is the weight. Now, yung mapapansin nyo, yung section properties na binigay, area moment of inertia and radius of gyration. So kung mapapansin nyo, the radius of gyration is already given. The length, effective length na mismo yung binigay, no? Effective length, ayan na, effective na siya. So since this is already effective length, you don't need to multiply it with your K. So ingat lang, no? Always double check or read the questions. So kung effective length na to, pwede nating sabihin na LE is already equal to your 6 meters, no? So R mo is ito na din. So R mo is ito. So pwede na natin agad makompute yung LE over R. Diba? Pwede na natin siya makompute. Natin. Ayun, LE over R agad. Then we will get the value 117.42. Diba? Next step is compute for your CC. Kasi yun yung basis natin. Ayun, substitute nyo lang. So here we have 126.17. So this is less than, diba? Yan, less than CC. So short. Yan. So yung formula natin may factor of safety. So compute nyo muna yung factor of safety given by the formula. Gagawin nyo lang is just substitute the given values. Then you will get your factor of safety. Then substitute nyo dun sa FA. Formula ng FA, sorry. Then ma-compute natin yung FA. Then after that, ang tinatanong, maximum axial load or maximum value of P. So yun, FA is equal to force over area. So your P is equal to AFA. So we will get your value of P. Now, this is an example of madaling problem lang. I mean, yung kasi binigay na yung R, no? Tapos effective length, okay na din. So nag-solve na lang tayo ng CC. Then FA to get your P. So I noticed most of the time na ang error ng students is given na yung R, nagko-compute pa sila ng R doon sa section, lalo na pag binigay yung cross-section ng beam. So again, kapag given na yung R and then hindi naman siya combined or built-up section, gagamitin nyo na yung binigay na R. So wag nyo nang pahirapan yung sarili nyo, no? So ulitin ko lang, palaging basahin yung problem ng maigi and then intindihin yung hinahanap para maiwasan yung errors. Okay? Next, let's have another example. Okay, so W310, 118 section with length of 8 meters, uses a column. Determine the safe axial load with Fy 345 megapascal. When first column ends are fixed, second, one end of the column is fixed, the other is free. Di ba pag fixed, di ba ang drawing natin, di ba pag fixed, actually kahit wag nyo i-memorize, i-visualize nyo lang, di ba kapag ganito yung, column, pag ganito yun kapag fixed. So ang K mo is equal to 0.5. No? As long as you can visualize the deformation, kahit wag nyo i-memorize yung value ng K, okay lang naman siya. So yan. Ends are fixed. Yung isa naman, one end is fixed, the other is free. Di ba pag free yung isa, that is 2. Check natin. Ayun, kapag fixed, you notice K is 0.5. So multiply nyo sa L to get your LE. Please notice, no, ang binigay dito is length lang, hindi siya effective length, so kailangan nyo ng multiplier. So yun, LE, then divided by the R. Yung R is given ulit. Now, if you'll notice, binigay yung radius of gyration sa X and Y. Now, again, least radius of gyration, so we will use 77.6. Ayun. Kaya yun yung ginamit natin. 77.6. And then CC, para ma-compare natin, again, 51 is less than 106.97. So, this is a short column. Diba? Short column yung equation na ginamit. And after computing your FA, you can get the value of your P. Yung isa naman, one end fixed, one end free, so multiplied by 2. Diba? So, LE over R is now greater than your CC. Therefore, it's long column. Tapos, use the equation for long column and then compute for your PC. So, ito yung examples ng very direct yung hinahanap. And then, madali lang kasi Isang section lang yung kinonsider, and then we have your Rx and Ry given as a problem. Okay, let's try this problem, no? Here, this is a built-up section. Okay, so we have a W530 by 290 section with 180 by 20 mm plate placed on top of the flange as shown. So this is used as a column with the length of 8 meters. So ito yung W530 by 290. Ito naman yung 180 by 20 na plate. So determine the safe action load of the column with FY345. Kasi ito yung section properties ng 530 by 290. Ito. Okay, so first, if the column ends are fixed. Next, if the column, next, kapag yung column ay hinged. Okay, so solve natin. Sorry. Oh. Nasaan na yun? Okay, so solve natin, no? Oh, let's have here. This is sample number 3. Hindi ko na lang. Column. Example 3. Na natin. And then we have going to copy the problem. And then I'm going to copy the section properties. So, ang binigay lang dito is 345 yung FY, length is 8, and then this is 180 by 20. So, para hindi ko na i-copy yung problem. Ito lang section properties. Yan. Yan. So, here, kung mapapansin nyo, no, dun sa section properties, binigay naman yung Rx. So, anong gagawin natin? Now, yung Rx na given, tsaka Ry, itong dalawa. Itong dalawa. These are for the W530 and 290 alone. Now, since this is an example of a combined or built-up section, we can't just use this kasi nga, itong dalawang to is for this W section only. So, ang kailangan natin is we need to get the radius of gyration of the combined section. So, paano ba natin siya gagawin? So, first step, lagay muna tayo ng X and Y axis, no? So, yung centroid nung is somewhere here. Diba, kapag nag-ano tayo, this is your X. Tapos ito naman, sorry, this is your Y, sorry. This is your Y. This is your X. So, kung i-drawing natin yung centroid nung parehas, di ba? Kung yung centroid nitong plate natin is nandito. Di ba? Andyan yung centroid niya. Yung centroid naman nung W section is, sabihin natin nandito. Yan. Kung mapapansin nyo, the location of the centroid is different along the x-axis. Kung mapapansin nyo, parehas yung direction nila, parehas yung y. Ang different lang nila, ang difference lang nila is yung location ng centroid along the x-axis. So therefore, we need to find the centroid of the group. Now, we will go back to your statics. To get the centroid of the group, we will use your Varignon's theorem. So to do that, Lagyan muna natin ng label para mas madali. So this is 180 by 20, no, yung sa problem. So this is 180. Ito, 180 to. So this is 180. And then this here is check natin. Lagyan lang natin ng label para mas madali. Magpaalin pa ba? Yan. Now, label. Ang height ng plate is, this is 20. Ang height naman nito, ang height nito is ito, depth, ito, 529. 529. Ano ba? So, ang gagawin natin, half ng 529 or yung distance nito is, so solve natin using your variance theorem muna. Again, ang hinahanap natin is yung centroid ng dalawa. Okay na sila sa y-axis. Ito lang yung centroid nito. So, di ba, using your variance theorem, or di ba, the total area multiplied by the centroid of the group is equal to the individual area times its individual centroid. Now, all we need to do is just get an origin dito sa section na to. Sabihin na natin na pwede kayong mag-origin sa top, pwede din naman sa baba. So, sabihin na natin na sa taas tayo magkuha ng reference line. Again, this is just a reference line. So, ang gagawin natin, etong y na to is, this is the distance of the centroid dun sa reference line natin. So, ayan na, ito yung equation, no? Dito ko na siya isusulat sa solve natin. So, ang area total is the area of this plate and the area of the I section. So, solve muna natin. Ang 80 is equal to, ang area ng plate is 180 times 20. Then, plus, ang area ng W section is andito. Ayan, ito. Ayan. So, 9484. So, ang area total natin is, let me get my calculator. We have 180 times 20 plus 9484. So, we have 13,084. Yan. So, yun yung area total. So, yun yung lalagay natin dito. So, ganun lang kadali. Is natin to. Gulo. Yeah. So, solving now, 13,084. So, yun. Write down, we have 1384 times the centroid is equal to area ng plate, 180 times 20 is 3,600. And then, the distance of the centroid with, papunta dun sa reference point, ito yung centroid niya. So, yung distance or bar y niya is ito. Gawin kong color blue din. Sige. Ito yung distance, di ba? Ayan. Ito yung distance na mangyayari. So, yung distance ng centroid ng plate is equal to 10. So, yun lang. Sulat nyo lang yung 10. So, you have here 36 times 10 plus the area of the plate, which is equal to, ilan ba yan? 9484. 9484. And then the distance of its centroid with respect to the reference line. So kung this is 529 divided by 2, ang distance nito is 264.5. Ito yung 264.5. Ito. So yan. Etong line na to is 264.5. Half. So 264.5. Now, distance nung centroid dun sa reference point. So 264.5 plus 20, no? So 264.5 plus 20 is 284.5. So yun yung so we will get now the value of your bar y. Ayan, bar y is equal to, if you have your calculator, you may try solving it then para sumabay kayo. We have 2484 times 284.5, and then please correct me if mali yung input ko. So bar y is 208.97. Yan. So saan ba magre-reflect yung bar y? Saan natin siya makikita? So yung 208.97, that is the centroid of the group, or centroid siya nung combined sections or combined materials. So ang mangyayari is, from the reference point, we will write the 208.97, and that will be the location of the new centroid. So from this point here, so galing dito, galing dito na dito. Sorry. Galing dito, kuha ka ng distance na 208.97. Kunyari yan yun. And then, horizontal line. This will now be the location of your new centroid. Gawin kong yellow. Ito yung location. At dito. Dito natin. This is now the location of your new centroid. So, lagay ko yung label. This is 208.97. No, bakit ba natin kinukuha yung new centroid? Because we need that to compute for your radius of gyration. Balik tayo dun sa equation before tayo mag-start ng compute. Erase ko na to, no? Erase ko na. Yan. So, di ba pag nagko-compute tayo, formula for your radius of gyration is equal to R. R is equal to square root of I over A. Now, we have your area. Di ba? Total area lang, 13,084. Now, your I, hindi pa natin alam or i-compute pa natin siya. Now, yung IY natin, you don't need to use the transfer formula. Bakit? Kasi yung centroid ng dalawang member, yung plate tsaka yung W section, pareha sila along the y-axis. So you don't need a transfer equation. So ang gagawin nyo lang is just add the moment of inertia along the y-axis. So how do we do that? Ganito lang. Raise ko ulit to. So yan. So for your IY no. We have IY. Dito na lang sa kabila. Sorry. For your IY, ito na lang. So your IY is equal to the I of the individual plates. So kung yung W section, given yung IY niya, 39.67 times 10 raised to 6. So copy nyo lang. 39.67 times 10 raised to 6. Next is the IY of the plate. Ang IY ng plate, since this is rectangular, just BH cube over 12. So plus base, di ba kapag IY, ang magiging base mo is ito. Ito yung base natin na ngayon. Ang height niya is ito. Di ba? Kasi along the Y direction yung hinahanap. So your base will be 20. B, height natin is 180. BH cube over 12. Then this will give you your IY. No, inad lang natin. Ulitin ko bakit? Kasi yung centroid nila is nandun lang sa isang direction. So add natin. Again, please double check na lang. 39.67 times 10 is to 6 plus 20 times 180 cube over 12. So your IY is 49.39 times 10 raised to 6 m4. Now, how about your IX? Again, yung IX kasi natin is wala sa isang X. So, itong new line na to, no, this will be your X-axis. Kasi andito yung centroid ng group. Ito. Now, recall in your statics, if we have a different centroid for the group, we need to use your transfer equation. Diba? So, using your transfer formula, so we have Ix is equal to summation of I plus A D squared. Again, general equation to, you should know this. Diba? This is, I think this was introduced in your statics. Dapat na-introduce sa statics na. So, yon. Ix is equal to summation of I plus AD squared. So, isa-isahin natin. Simulan natin sa plate. Simulan natin sa plate. Kung ito binorsiya ng plate, BH cube over 12. So, ang base mo na is 180. So, then, ang height mo is 20. BH cube over 12. Plus the area, 180 times 20 is 36. Now, ano ba yung D? Yung D is the distance of the original centroid to the new centroid. Please don't forget that, no? So, yun yung distance ng new centroid sa original centroid. So, ang centroid natin is etong point na to. Ang new centroid mo is ito. So, yung hinahanap natin is itong height na to. Ito. Which is equal to 208.97 minus 10. Di ba? So, 8.97 minus 10. So, this is 198.97 squared. Again, this is just for the plate. Add pa natin yung sa W section. So, for the W section, ang I niya is Ix 4.096 times 10 raised to 8. So, 4.096 times 10 raised to 8. Lagyan ko nito para di kayo malito. Ito yung sa plate. Ito naman yung sa W section. I plus AD squared. Ang area niya is 9484. Ang D naman is distance of the original centroid nung W section. Tapos, with respect to the new centroid. So, ito naman yun. Ito. Diba? Ito yun. Now, kunin nyo lang yung distance na yan. Madali lang naman. So, add nyo to. Subtract nyo to. Diba? Para makuha nyo yung height na yan. So, 264.5 plus 20 para makuha nyo yung height na to, no? Then, subtract nyo yung 208 minus 208.97. This is 75.53. 75.53 squared. Yan. Now, we can now get your Ix. Please compute. Para ma-check, baka mamali ako. So, 180 times 20 cube over 12 plus 36, 8.97 squared. Next. So we have Ix is 604.91 m times 10 raised to 6, 10 raised to 6. Okay, so please correct me if I'm wrong. Baka naman hindi din ako ng input, no? But after calculating it, ito yung lumabas. We have 604.91 times 10 raised to 6 mm raised to the 4th. Now, what's next? What's next is compute natin yung radius of gyration. And then we will get the least value. So, substitute nyo lang sa equation na R, gawin natin magiging Rx is equal to square root of Ix over A. Ang A is the total area. So, yan. Paki-compute. So, square root of 604.91 times 10 raised to 6 divided by the area. Ano yung area natin? 13084.215. Ry naman natin, square root of Iy over A. So we have 49.39 times 10 raised to 6. Sorry. Square root of 14, ano nga yun? 49.39 times 10 raised to 6 all over the area, 13,084. So, yung Ry natin is mas maliit, 61.44. So, di ba, yung sabi natin, we will use the least value of radius of gyration. So, we will use your 61.44 mm. So, ang haba ng process, no, ang hinahanap lang natin is yung R. Nagtataon kasi dito na hindi siya, I mean, a built-up section siya. So, ulitin ko, no. First step is get your centroid. Ulitin ko, yung Y kasi is nandun na siya sa Y-axis. So, ang ginawa lang natin sa moment of inertia ng I is inad lang natin siya. Yung X kasi is magkaiba. So, hinanap natin yung centroid ng group. And then, we use the transfer equation or transfer formula, ito, to get your moment of inertia. Yan. So, after getting your R, ito lang naman yung mahaba dito. Ang mangyayari na ulit is after getting your R, doon na tayo sa LE over R. Diba? LE over R, gawa tayo ng another page, hindi na kasha. Copy ko na lang dito. Ang na-compute natin na R is 61.44. Yan, palagay natin. So we have R, Ry, ito yung lalagay natin, 61.44 mm. And then, copy na natin sa problem. Ang length is 8 meters. Length is equal to 8 meters. Then, question number 1. Okay. Check ko lang. Yan. Yan. Column ends are fixed. Column ends are fixed yung tanong. Yan. So, A, di ba pag fixed K is equal to 0.5. Tapos, compute lang natin yung LE over R, which is now equal to 0.5 times your R length, which is 8,000. all over your radius of gyration na na-compute natin, 61.44 is equal to, check natin, 0.5 thousand divided by 61.44. 61.44. We will have 65.104. So ito yung LE over R. Ano yung next step? Diba after this, makompute nyo yung CC. After nyo makompute yung CC, makaklassify natin if long or short column. After that, compute nyo yung FA, and then after that, compute your P. So, for this example, hindi ko na siya isa-solve manually, bibigay ko na lang yung solution. Pero, ang importante lang kasi dito is, na-discuss ko ito because if you encounter a problem na hindi siya symmetrical or magkaiba yung centroid ng dalawang member, you would need to compute for the value of your Rx and Ry. So, most of the time, ang ginagawa natin is, kinocompute lang natin yung Rx saka Ry, tapos kinukuha natin yung value ng R na least. Kasi ang gusto natin, mas mataas yung LE over R. Diba? The smaller the denominator, mas mataas yung value. So, there are cases na kailangan natin isolve yung LE over Rx saka LE over Ry. Kasi hindi ibig sabihin na mas maliit yung Ry mo is mas malaki yung makukuhang value. So, I will be showing you that sa next problem natin. So, ito yung important. So, I will save this and then give you a copy. Ito mismo. Yan. Yeah. Then, let's go to problem number. Ito. So, here, built-up section ulit. Consisting of W350 by 90, itong I na to. And then, may dalawang 12 mm plates to form a box. So again, this is the top view or cross-section siya nung column. Okay, the column is fixed at both ends. So KE is equal to 0.5. Along the x-axis, fixed at both ends siya. Pero braced at mid-height about the weak axis or y-axis. So magkaiba yon. Along the x-axis daw, column is fixed at both ends. Along the y-axis, may bracing siya sa gitna. So I will show you kung paano siya later on. So ito yung FY 248 properties. Okay, so determine the following. First, effective slenderness ratio with respect to lateral buckling about the x-axis. Next, slenderness ratio with respect to lateral buckling about y-axis. And then the axial load. Okay, so copy ko ulit yung problem. This is column example 4. Yan. Copy ko yung figure. Ayan. Masyadong malaki pa natin. Pag need ko yung properties. So, copy ko lang. Yan. Ano pa ba? 12 mm yung plate. Okay. Sige, ito yung property. 248 yung FY natin. Ito ko na lang yung property. No? So, first step is label muna natin. Yung flange width or BF is 250. So, ito daw is 250 ito. This is 250. Ang depth niya naman is 350. So, ang magiging haba ng plate is 250 din. This is 250 also. Ayan. No? 250 din. Sorry, 350. And then, the thickness, 12 mm yung plate, no? So, sige, sulat ko na lang. So, yan. Yan, para mas malaki. So, maybe, this is, so yung 12 mm, 12 mm na. 12 mm. Then, yung dimension is, flange width is 250, depth is 350. Pinusin dyan, 250. 250. Tapos ito naman, 350. So, ano yung gagawin natin? First, drawing nyo muna yung centroid ng mga members. So, kung i-drawing natin yung centroid ng members, di ba, saan sila? Ito yung isa sa W. Ito yung centroid niya. Ito naman, ito yung centroid. And then, this is the centroid. Second step, gawin natin, di ba, is with, lalagay natin yung X and Y axis. Gawin ko na lang green. So, ito yung Y-axis. Y-axis. And then, the X-axis. Yan. Diba? Na kung mapapansin nyo, anong mapapansin nyo? Diba? Unlike the previous example, here, lahat sila along the line of your X-axis. Diba? Ito yung X-axis. Along the line of the X-axis. Tapos, iba-iba sila, wala sila sa Y-axis. So, therefore, ang kailangan ng transfer formula is yung Y direction or yung IY, di ba? Ganun lang yung pag-analyze kung alin ba yung kailangan natin ng transfer formula, yung X ba o yung Y. Now, kung lahat sila along X-axis, so all you need to do is add the moment of inertia sa X. Yung sa Y naman, wala sila sa centroid, so gagawin natin is ita-transfer natin sila sa centroid of the group. Now, kung mapapansin nyo dito, symmetrical siya, so medyo obvious na ang centroid ng group is nandito din sa gitna. Andito din yung centroid. Diba? Yung varignons kasi ginagamit natin siya kapag hindi symmetrical yung section kasi hanapin natin yung centroid. Now dito, syempre yung centroid nitong dalawa is obviously kung ita-transfer natin yan, nandito yan sa gitna. Nandito yan sa gitna. So, we don't need to use Varignon's theorem and then get the reference point. Ito na agad yung magiging centroid ng group sa gitna nung I section. So, unahin natin yung madali, no? Compute natin yung IX. Natin yung IX. So, IX is i-add lang natin. So, IX equal to, unahin natin yung W section. IX is 266. Ito yun. Times 10 raised to 6 plus the moment of inertia along the x-axis ng dalawang plate. So, ang base nila is 12. BH cube over 12. Base is 12. Height is 350. Cube over 12. Now, since dalawa yan, so times 2. So, you can get your IX. Add lang natin. So, 266. 766 plus So this should be around 351.75 times 10 raised to 6. Please double check. Wala kami mali ka na. Natin. And then for the IY naman, di ba? IY naman is gagamitin natin yung transfer equation since ita-transfer natin siya sa isang centroid along the y-axis. Now, unahin ulit natin yung W section since it's already at the point or nandun na siya sa centroid. Copy nyo na lang yung IY. Ito. So, 44.54 times 10 raised to 6. Again, yung transfer equation, ginagamit natin siya dun sa members, nita-transfer natin yung centroid. So, since yung IY is nandun na siya, no, hindi na natin gagamitan. 10 raised to 6 plus yung centroid ng dalawang plate. Lagyan ko nito para di nakakalito. Using your I plus A B squared. I ng dalawa, we have, again, ang magiging base nyo is ito. Ito yung magiging height. Kasi maraming namamali doon, no? Na nineglect nila. Ay, nakakalimutan nila na ito dapat yung base. Ito naman yung height. So, base natin is 350. Ang height natin is 12. So, BH cubed over 12. Plus the area, 350 times 12. Times the D, again, ang D natin is the distance of the original centroid to the new centroid. So, kung 250 to, ito yan, di ba? Ito yung distance na tinutukoy natin. Yan. Sorry. Yan. Itong portion na to, which is, madali lang naman na-compute. So, kung 250 to, this is 125. 125 plus 6. So, 125 plus 6. Hindi ko nasusulat, no? Lagay ko na lang dito. This is 131 squared. Now, this is just for one member. Now, since dalawa yan, multiply ko to sa 2. Dalawa yan, parehas lang naman yung distance and symmetrical nga. So, this will be the equation for your IY. Tapos, compute na lang natin yung IY nyo. 44.54 times 10 raised to 6 plus 350. Again, paki-double check na lang with your calculators to see if tama. 12 plus 350. Something squared. Should be 188.79. Yan. Okay, so now, di ba, kung regular tong column, ang gagamitin na natin is yung IY. But, according to the problem, along the x-axis, yung bracing niya is fixed at both ends, pero sa y-axis may bracing sa gitna. So, ganito yung magiging itsura niya. Ito dito sa baba. So, kunyari, ito yung column natin. Kunyari yan. Tapos, di ba, kung fixed at both, ito yung along x. This is along x, no? X. So, fixed at both ends lang. Diba, ganyan. So, ang mangyari, your K is equal to 0.5. Tama. Kasi wala naman siyang changes. Now, yung sa y-axis daw, y naman to. Again, same pa din, fixed at both ends yan. Sorry. Pero may bracing daw siya sa gitna. So, lagyan natin ng line sa gitna. May bracing daw. Now, what does this indicate kapag may bracing sa gitna? Ang gagawin natin, ay, nawala. May bracing daw sa gitna. Ano ibig niya sabihin? Ang mangyayari dito is i-assume na natin to na pin supported to. And then, ang i-consider lang natin is half ng column. So, yung length is, this is 10 meters. No? This is 10 meters. So, for this section, LE is equal to 10 times 0.5. Ito naman, since hinati siya sa gitna, this will be 5 meters. And then, magiging tong fixed support tsaka pin connected. Diba? Kapag fixed tsaka pin, ang magiging buckle niya is ganito, diba? Ganyan. So, ang magiging KE natin dito is 0.7. Okay, so, ganun lang yung gagawin. And then, since so yun na. So, ang magiging LE natin dito, LE is equal to 0.7 times 5 meters only. So, yun yung mangyayari, no? Instead, ganun kapag may mid-height support. So, X and Y. So, instead of just considering your least value of your R, di ba, I pa lang pala to. Compute pa natin yung R, di ba? Instead of computing just for your R, kailangan natin i-consider both yung X saka Y. So, isahan ko na, huwag ko na i-compute yung R para mabilis. Isahan lang. So, for the x-axis, sulat natin, we have, x-axis, saan na yun? Ayan. So, KL or LE over RX is equal to, ang LE natin is, dapat naka-mm, so 0.5 times 10,000 all over RX. RX is square root of I over A. Pwede naman na i-solve nyo muna. So, diretsuhin ko na lang. So, we have here 351. 0.75 times 10 raised to 6. All over the total area. Sorry, ilan ba yung total area? Pinapit ko na ba? Ay, hindi pa. So, compute ko 80. 80 is equal to 11,550 plus 12 times 350 times. So, compute nyo muna para madali. 11,550 plus 12 times 350 times 2 kasi dalawa. So, 19,950. Lagay ko lang siya dito. So, 19,950. So, LE over RX is equal to, sulat ko naman yung sa RY, ganun lang din. So, LE over RY. Ang LE natin is 0.7 times 5,000. So, 5,000 all over square root of, copy nyo yung IY, 188.79 all over area, 19,950. Now, kapag nagka-calculate kayo, please do not, wag kayong mag-round off. Store nyo sa calculator. Kasi kapag, lalo sa board exams or exams, no, yung final answer is, most of the time, yung final answer sa choices is nakuha ng hindi nag-round off. Ang ginagawa kasi po nag-solve is store mo na siya. Kunyari yung IX, store mo sa A, IY, store mo sa B, kasi di ba mahaba yan. And then, siya mismo yung gagamitin mo. So, substitute mo na lang yung constant sa calculator instead of writing just this. No? Kasi mag-iiba yung sagot. So, if you stored the value, ito yung lalabas. This is 37.66. And then yung RY natin is 35.98. Yan. So we have two values of your LE over Rx. Now, di ba, sabi ko, we will use your least value of radius of gyration. Again, ang purpose nun is para ang makuha natin is yung mas malaking value. So here, di ba, most of the time, RY yung ginagamit natin. Now, in this case, kung mapapansin nyo, mas malaki yung value nung LE over Rx. So, ang tamang LE over R na gagamitin natin is ito because this is bigger. So, ito yung case, some of the cases wherein ang gagamit natin is Rx instead of Ry. Kasi most of the time, lalo kapag uniform naman or same naman yung support sa X and Y, palagi dyan, most of the time, Ry. Ito lang example ng mga cases na nag-prevail yung sa X-axis natin. Yan. So, yon. After getting your LE over Rx, ito na yung question. Tama? Ito ba yung tanong? Check natin. Ito yung tanong. Ayun. Yan. Tanong, effective slenderness ratio with respect to buckling at X. So, nakuha na natin. Effective slenderness ratio with respect to Y. Nakuha din natin. Next will be the axial load. So, di ba, after this, same lang yung gagawin natin. We will compute for your CC. So, compute tuloy natin. Dito natin. What's this? Natin yung CC. So, CC is equal to square root of 2 pi squared. Your E is 200 na. 200,000. All over Fy, which is 248 to 48. So your CC will be 126.17. And then, obviously, mas malaki siya sa LE over R. Ito na. So, short column. So, ang gagamitin natin is yung formula na may Fs. So, factor of safety is equal to 5/3 minus 3 over 8. LE over R yun. So, 37.66. All over LE over R over CC. Yan. 126.17. Ito dapat. 17 minus 1 over 8 times LE over R, 37.66 over 126.17 cube. So, makumpute natin yung Fs. Okay, so, yung question na, ma'am, dapat ba namin itong i-memorize? Sa board exam kasi, there are times, most of the time naman is binibigay yung nscp specification. So, nakalagay naman dun yung mga formula. So, sa final exam kasi, the coverage of your final exam will be the entire steel. So, i-indicate ko yung equations. But for the midterm, hindi siya kasama. So, you need to familiarize yourself with this. Now, just to be sure, yung iba is palaging mini-memorize to, lalo sa board exam. Pero, most of the time naman is naka-indicate siya sa problem. Okay. Mahaba lang kasi siya. Lalo yung short. So, yun. The value of your Fs is 1.775. And then, Fa naman. Fa is 1 minus 37.66 cube over 2 times 1. 17 times Fs. Solve natin. Sorry, nakalimutan ko yung Fy 248. So, yun na yung Fe. And then, after Fa, diba, Fe is equal to P over A. So, P area Fa. So, yun na. Complete na natin. Area is 950 times your Fa, 133.49. So, your P is divide 1,000 para maging kilonewton. 266.9. Ayan, ito yung actual capacity ng column. So kung mababasa nyo, ang medyo tricky lang na part is kapag yung pagkuha ng radius of gyration or yung slenderness ratio. So pero once naman na may intindihan nyo yung pag-analyze ng beams, ng columns, especially if they are built-up section, all you need to do is get the R and then get the limiting slenderness ratio and then use the corresponding formulas dun sa short and long column. I think ito na yung sagot sa number 4. Yan, number 4. Yan. So, punta tayo sa next example. Yan. Next example. So, here we have, ano ba yan? A compression member. Tama ba? Yeah. Compression member of a steel truss 3 meters long consists of 2 angles, 150 by 100 by 100, with long legs back-to-back, spaced 10 millimeters apart. Properties of the angle. Now, assuming that the ends are hinged and using nscp specification, determine the following. First, allowable axial stress. Second, safe axial load that the member could carry. And third, long legs, back-to-back spacing to be equally strong at both axes. For example, this is a truss. Again, truss are subjected to axial forces. Now, in this particular problem, no, ang nakalagay, a compression member of a steel truss. So, we may use the equations kasi compression member ng truss yung tinutukoy dito. So, we will use the same analysis. No? Copy ko lang yung properties. 3 meters long. Length is 3 meters. 2 angles, 150 by 100 by 10. Back to back, 10 apart. Sige. Solve natin. This is column example. Column example 5. Properties. Dito ko. Ano pa? Yeah. Need natin to para ma-drawing natin. Steel truss, 3 meters long. So, double angle yung member ng truss, tapos back-to-back daw sila. So, kung i-visualize natin siya, mga ganito yan. this is 150 by 100. So this is an angle bar to. So ganito. Ay, sorry. Yan. Shape L. Tapos, back to sila. Back to back. Yung masalak sige. Ito na lang bago. Same yung properties ng L, no? So yan, back to back daw sila. Hindi pantay. So yan, back to back. Tapos may spacing sila na 10 mm apart. So ito. 10 mm apart. So lagyan natin. This is 10 mm. 10 mm. Ano pa ba? Ayun. So properties of the angle. Now, yung centroid, most of the time naman is, since hindi siya regular shape, di ba? Given na yan yung centroid. So, andito nakalagay, properties of an angle. Ayan. So, nakalagay yung X tsaka Y. So, yan yung location ng centroid ng isang angle. So distance niya sa X, 23.75. Distance niya sa Y is 48.75. So, mga nandito. Sabihin natin, nandito yung centroid ng isang angle. 23, tapos 48.75. Andito din yung centroid ng isa. Ganyan. Tapos, di ba yung second step natin is, sorry, malabas. Second step natin is ilagay natin yung X and Y axis. So, X axis, since pantay sila, lagay mo na dyan yung X axis. Yan, X axis. Tapos, Y axis. Yan natin. Of course, dapat nasa gitna yan. Yan. So, again, para malaman natin kung gagamit ba tayo ng transfer equation or hindi, titingnan natin kung nandun ba siya sa centroid or nandun siya sa X and Y axis. Kung mapapansin nyo dito, they are both along the X axis. So, add lang natin yung IX ng dalawa. Now, yung centroid ng dalawang angle is wala siya sa y-axis. So, gagamit ulit tayo ng transfer equation para sa y. So, sorry, this is your x. This is your y. This is 10 mm. Tapos ito, no? Paano ba? Itong distance na to, this is 23.75. Nakihan tuloy natin. So, itong distance na to, no? This is your 23.75. Ito naman distance na to. This is your 48.75. Yan. Now, compute natin, unahin natin yung mas madali, which is your IX, kasi add lang natin yung IX. Now, since these are the same type of angle, times 2 na lang natin. So, madali lang, no? Ix is equal to, sorry. Ba't lumalabas to? Yan. Ix is equal to, copy nyo lang yung Ix nito, ito. So, 5.58 times 10 raised to 6 times 2. Kasi dalawa sila. Same lang yung type ng angle. So, 5.58 times 10 raised to 6 times 2. So, we have 10 raised to 6. 11.16 times 16 times 10 raised to 6. So, the fourth. Now, yung IY naman, both sila ito transfer natin. Now, ang centroid is ito. Diba? Ito dapat yung centroid nila. So, ang magiging D is distance nitong original papunta dun sa centroid ng group. Which is dito. Again, dito, you don't need to use Varignon's theorem para malaman kung nasan yung centroid along Y, di ba? So, obviously, dito sa gitna ng dalawa. So, sulat natin. So, IY. Multiply ko na lang sa 2 since parehas lang naman sila. So, 2 times, again, transfer equation I plus A T squared. Now, IY nila is given din sa section property. Ito siya. So, we have 2.20 times 10 raised to 6 plus the area. Given din, ito, plus 2,400. Then, yung D, yung D is yung distance ng original centroid papunta dun sa new centroid. So, your D is 23.75 plus 10. So, this is 5 na. So, 23.75 plus 5. So, you have 28.75 squared. So, yan. You will now get your IY. It's equal to 2 times plus 2, 4. Highway natin is 8.3. 36 times 10 raised to 6. Dito yung tanong, double check na lang. Ano ba yung tanong nga? C. Ito yung tanong. Allowable axial stress, safe axial load, tsaka long legs, back-to-back spacing to be equally strong at both axes. Okay, so to get your to get your FA, compute natin yung R. Diba? So, you have Rx equal to square root of Ix over A. Hindi ko na isusulat. Ilagay na lang. Ilalagay ko na lang din. Ry is equal to square root of Iy over A. Yan. Square root of Ix. 5. Over. Ang area natin is, ilan na nga yan? 2,4 times 2. Kasi dalawa sila. So, times 4,800. Dalawa yun na. So, times 2 dapat yung A. 48.21. Now, store nyo yung answers para yung sagot nyo is over area 48. .75. So here, use the least radius of variation. Tama ba? Yan. Try natin LE over RX. Ang LE, ano na nga yun? Hinge at both ends ba? Check ko. Okay, so hinge daw. So LE is equal to 1. So you may do this or dire-diretso na lang yung KL over RX. So LE over R is equal to 1 times the length. Steel truss is 3 meters long, so 3,000. All over RX 48.21. So kapag hindi kayo nag-round off, ang lalabas dyan is 66.22. LE over RY naman. Kapag hindi rin kayo nag-round off, natin. Square root of mga sorry. We have square root of square root 8. Yan, mali nga ako. This is 41.75. Yeah. So, LE over RY over 41.75 is equal to. Okay, so, pag hindi ulit kayo nag-round off, this will be 71.85. So, yan. Now, compute for your CC to analyze kung ano ba yung type of column. Ulitin ko, di ba? Ang gagamitin natin is the larger LE over R. Pero actually, kahit hindi nyo na ito kinumpute, no? Kasi same lang yung sa X and Y axis. If we use the least radius of variation, 41.75, ayan, makukuha natin yung bigger value of LE over RY, which is 71.85. So, chinek lang natin. So, tama. Then, compute for your CC. CC is square root of 2 pi squared E over Fy. Hindi ko na isusulat yung value. Sagat na lang. 250 yung Fy. 230. Okay. Now, greater yung CC. So, this is again short. So, compute for your Fs. Hindi ko na isusulat yung equation. No? Calculator na lang. Sige, sulat ko tuloy. We have 5/3 minus 3 over 8. LE over R is 71.85 over CC 131.03 minus 1 over 8 71.85. Actually, kapag sagot kayo ng sagot ng mga similar problems, mas mapapabilis yung pag-familiarize nyo dun sa equation. So, habang tinatype ko yun. Then, compute for your FA. Ito yung tanong sa number 1, no? FA is equal to... Substitute ko na lang, no? This is the equation I gave you. 1 minus LE over R, which is 71.85 squared over 2cc squared times Fy over Fs. This will give you 105.51. Okay, so question number 1. Ito yung sagot. Allowable axial. Letter E. Next, sa letter B, what is the, ano ba yung tanong doon? What is the axial load? So, madali lang naman, di ba? Pag nakuha mo na yung FA, masasolve mo na din yung P, kasi P is equal to AFA. Then, di ko nasusulat. Multiply na lang natin. 105.51 times 4.8. So, will give us 506. Divided by 1,000 para maging kilonewton. 0.45. Yeah, so this is now your B. Ano yung C? Ano daw yung C? Long legs, back-to-back spacing to be equally strong axis. Anong ibig sabihin? Kasi di ba yung x-axis is also known as your strong axis. Tapos yung y-axis naman is also known as your weak axis. Now, ang kailangan natin is the distance para daw maging equally strong sila. So, sinasuggest na dun mismo sa problem, no? So, dapat equal yung x tsaka y. So, ang gagawin natin is we will equate the moment of inertia of your x and y axis. So, ganito ang gagawin natin. So, no? Ang sabi kasi distance daw para maging equally strong sila. So, gawin natin I about the neutral axis, no? Neutral axis sa x-axis should be equal to the moment of inertia sa neutral axis ng y-axis. So, equate natin siya para daw maging equally strong sila. So, ang hinahanap natin is spacing. Now, yung spacing is given dito sa problem. Now, what we want is to have an equal value of Ix and Iy. Tapos, hahanapin natin yung distance. Sabihin ko yung distance. To, magiging variable to. Gawin natin distance D. No? Yung distance D yung hinahanap. Now, yung distance na to is magdi-differ lang siya sa y, no? Sa moment of inertia sa y. So, all we need to do is solve natin. Yung Ix, ang gagawin nyo is i-copy lang natin yung Ix kasi hindi naman siya magbabago. So, 11 point, ano nga yun? 11.16 times 10 raised to 6. 16 times 10 raised to 6 is equal to the moment of inertia sa y. So, ang mangyayari lang, kung mapapansin nyo, ito, di ba, transfer equation. So, instead of having a distance na 10 mm, papalitan natin siya ng d. So, instead of 28.75, no, ang gagawin natin is magiging siyang 23.75 plus d over 2. So, ganun yung mangyayari. D over 2 or 0.5d. Na, so, alisin natin to. Kukunin natin yung d. Kasi, para mahanap natin yung distance wherein equal yung moment of inertia ng x and y axis. So, ganoon lang. Solve natin. So, magiging 2 times 2 point, kakopy ko na lang to, no? 2.20 times 10 raised to 6 plus 2,400. Ang distance niya is 23.75 plus d over 2. Ayan. Na kung mapapansin nyo, ang only unknown here is your d. So, makukompute natin yung distance. Wherein, yung distance na magiging equal yung strength along the x and y axis. So, ito yung ideal distance if you want an equally strong axis. So, yan. So, kung i-compute natin to, your d will be equal to, check natin, 11.16 times 10 raised to 6 divided by 2 minus 2.2 times 10 raised to 6 divide 2, 4. Divide 2, 4. Then minus 23.75 times. Huwag kayong mag-round off, no? Yun. Kaya pala may mali. It should be squared, no? Squared. Naka-squared siya kasi D. Sabi na may something wrong. Sa value ko ulit. 11.16 times 10 raised to 6 divided by 2 divided by minus 2.2 times 10 raised to 6 divided by 2, 4. Times 2 square root answer 27.58. Now, I suggest na kapag nagsosolve kayo, parang sa bilis yung sagot, just use your algebra na simplify nyo na muna siya para ma-solve nyo yung D. Kasi if you use shift solve na ganito kahaba yung equation, masyado yung mabagal. Okay, so we have now solved for your letter A, letter B, and letter C. So this is how you compute for your, yan. So, ayan, key for solving a problem is you need to be able to visualize the problem first para may start kayo. And then, if yung problem is hindi siya symmetrical or you would need to have a change sa centroid or mag-transfer sa centroid, kailangan nyo nga nang ilagay yung x and y axis para ma-figure out nyo kung alin ba yung kailangan nyong i-transfer. And then, tsaka nyo i-solve. As long as makuha nyo naman yung RX, yung radius of gyration, dire-diretso naman na yung pag-solve. Okay? So ito, again, tulad nung sabi ko, typical is yung RY yung magpi-prevail para makuha mo yung slenderness ratio. But there are cases like the previous example wherein you need to consider the X and Y axis kasi magkaiba yung buckling nung X and Y axis. Yan. Okay, so that would be the last example for your actually loaded column.